Hello students. In this video I'll be starting with data structure unit 2. Chapter is sorting techniques. There are so many techniques, but in this video I will cover only three sorting techniques: bubble sort, insertion sort and selection sort. Now we'll start with the first topic. First type is bubble sort. Now we'll see the procedure how this bubble sort works. Now you'll have this, you can see that there are different procedures, there's a different different methodology how it works, but I will show you that how the number of elements and how it works. Now see with this, now see here, the main objective of this sorting is to place the greatest number at this last position. Now there are how many numbers? 40, 10, 20, 30 and 50. So we have to place the greatest number at the last position. But for this particular element, 50 is the highest number. So we have to place this number at the last position. But in this section, the elements which are given, the 50 is the highest number, so it will be at the last position only. So you can see one by one here. So we'll sort the array by using bubble sort. We start with the first two elements. So here we'll see that first two elements, that 40 and 10. We'll compare 40 and 10. So here 40 is the greatest number. So 40 will be at the second position. Then in the next step, now we'll compare the second and the third element. Now you can see here 40 and 20. So again this 40 is greater than 20. So here that 40 is greater than 20. So 20 is small. So you will swap the values. Again we'll check this next two numbers, means that is third and fourth number. So here again this 48 is greater than 30. So again you can see that 30 is smaller than this 40. So that will be swapped here. Now next number, again if you compare with 40 and 50, so already this 50 is greater than this 40, so that means 50 will not be swapped. Why? Because already it is at the last position. So this is the procedure, and in this procedure we will be placing the greatest number at the last position. Now we can see one more example here. If you see here, these are the numbers 5, 3, 8, 6 and 8, 4 and 6. As per this definition, objective of this sorting is to place the greatest number at the last position. You can see here, we'll place this number, that is the 8 is the greatest number at the last position. So in this step number 1, we'll see that first two number, that is 5 and 3. Here 5 is greater than 3, right? So it will be swapped here. So first and 2 will be swapped. Now in the second step, the elements will be like 5 and 8 here. So 5, 8, again 8 will be compared, but 5 is smaller than 8, so it will not be swapped. Now in the next step we'll compare this 8 and 4. So here eight is greater than 4. Now again it will be swapped here. Then in the next step 4, this 8 and 6, here 8 and 6, so 8 and 6 will be compared. So now 8 is greater than 6 here, so again this will be swapped, and finally this greatest number is placed at the last position. Now this process will be repeated. Now I will see you, show you this particular steps. In unsorted list of 5 elements which we have taken in the next slot, start with the first two elements and sort them in the ascending order. So basically we are comparing first two numbers. If the first number is greater than the second number, we will exchange, and if it is not greater, then we will not exchange. Compare second and third element to check which one is greater. Again third and fourth, again fourth and fifth, and so on till we are not placing the greatest number at the last position. So this is what this is called as bubble sort. In this way we can place all other numbers for placing the numbers in the sorting order. Now we'll have the next type is insertion sort. In the insertion sort algorithm, it arranges a list of elements in a particular order. In insertion sort algorithm, every insertion moves an element from unsorted position to the sorted position until all the elements are sorted in the list. Now you can see the steps, different steps. Step number 1, assume that the first element in the list is in sorted position and all the remaining elements are in unsorted position. Now you can see the list here. These are the elements here: 15, 20, 10, 30, 50, 18, 5 and 45. So these are the unsorted list. Now if you choose one list will become sorted and the remaining will be unsorted. So as per this insertion sort, we have to start from 1 and then we'll go to the next element, we'll go to the next element. So this is the first step here. Now step number 2, take the first element from the unsorted portion and insert that element in the sorted portion in the order specified. So what I said, we'll make two different lists, one is sorted and one is unsorted. So here initially all the elements will be unsorted in the unsorted list. Now we'll choose the first element and we'll keep in the sorted list. So now here 15 is the first element, so move the first element 15 from unsorted portion to the sorted portion. So here 15 will be in the sorted portion and remaining element will be in the unsorted portion. Now step number 3, repeat the above process until all the elements from the unsorted portion are moved into the sorted portion. Now you can see here in the first step I have taken 15. Now I will take 15, 20, and again I will compare this 20 with the first element, right? So to move element 20 from unsorted to the sorted portion, compare 20 with this 15 and insert it at the correct position. So here 20 is greater than 15, so it will be placed after this 15 only. Now go to the next step. Now we'll choose the next element, that is 10. So now this 10 will be compared. So here 10 is greater than, smaller than 15. It will be placed before 15. So now you can see here this 10 is placed before this 15 only. So now this 10, 15 and 20, all the three elements are in sorted position. Now in the next process we'll choose this next element, that is 30. Now 30 will be compared with all the three elements here which are in the sorted order. Now you can say that 30 is greater than 20 here. So now this 30 will be placed after 20. Now after putting this number 10, 15, 20 and 30 all will become sorted. So here you can see here that 10, 15, 20 and 30 are in the sorted order and remaining elements are in the unsorted order. Now we'll again choose the next element, that is 50. So 50 will be compared with all other elements from the sorted list. Now 50 is greater than all the elements, so 50 will be placed after 30 only. So after comparing now this 10, 15, 20, 30, now all the elements will be in the sorted position. Now the next step, this 18 will be compared with all the elements from the sorted list. Now you can see here 18 is greater than 15 and smaller than 20. So this 18 will be placed after 15 and before 20. Now you can see the list. Now 18 placed between this 10, 15, 18, 20, 30 and 50. All are sorted numbers. Now next I will choose the next element, that is 5, which will be compared with all the elements from the sorted list. Now this 5 is smaller than this 10. So this 5 will be placed before 10 only. Now in the next list you can see 5 placed before 10. So 5, 10, 15, 18, 20, 30 and 50 all are in the sorted position. Now the last element we will choose and will compare with all the elements from the sorted list. Now here 45 is greater than 30 but smaller than 50, so it will be placed after 30 and before 50. So you can see this, all the elements are in sorted order. So final list is 5, 10, 15, 18, 20, 30, 45 and 50. So this is the final list of insertion order. Now we'll move to the next sorting technique, that is called as selection sort. First of all, we'll see how this algorithm works. This algorithm will first find the smallest element in the array and swap it with the element in the first position. Then it will find the second smallest element and swap it with the element in the second position. And it will keep on doing this until the entire array is sorted. It is called selection sort because it is repeatedly select the next smallest element and swap it into the right place. Now you can see the elements. Now you can see here, these are the elements 3, 6, 1, 8, 4 and 5. Now we have to select the smallest number and then it will choose the elements and it will be replaced from the first position. Now see that how it works. Starting from the first element, we'll search the smallest element in the array and replace it with the element in the first position. Now see, the elements which are given, that 3, 6, 1, 8, 4 and 5. In the first step, now you can see that 1 is the smallest number. Now what the algorithm says, we have to select the smallest number and we have to replace with the first position number. Now, so this 1 will become at first place and the 3 will become at the third place. So then first number will be sorted. Now we then move on to the second position and look for the smallest element present in the sub array, starting from index 1 till the last index. Now we can check here, this first position is already sorted. Now what is the next sorted element, smallest element? Now you can see here, expect the first element. Now the remaining element, from the remaining element, which one is the smallest number? Now this 3 is the smallest number. So what the second point says, we have to choose the second smallest number and we have to place at the second position. Now we'll replace this 3 from the second place number. So now we'll put this 3 here and 6 will be placed at the third position. Now after this second step, now you can see in this third step, 1 and 3 both are sorted. So this process will be repeated. Now you can see, we replace the element at the second position in the original array and we can say at the first position in that sub array with the second smallest element. This is repeated until the array is repeatedly sorted. Now you can see, after the third pass, what we'll do, in the second pass, 1 and 2, first position and the second position both are sorted here. Now from the remaining elements 6, 8, 4 and 5, we'll choose which one is the smallest number. So here 4 is the smallest number. Now we'll replace this 4 at the third position element now. So this is 1, 3. Now this 4 will become at the third place. So this is 1, 3 and 4, all will be sorted here. Now the remaining elements are 8, 6 and 5. So again this process will be repeated again here. Now this 5 will be replaced with the fourth place number. So in the next step you can see that 1, 3, 4 and this 5 will become at the fourth place. So here 1, 3, 4 and 5 all will be sorted. Now again we will check in the next step here. So that remaining that 6 and 8 both are the remaining elements. Now we will check which one is the smallest number. So this here 6 is the smallest number and which is at the right place. And again this 8 is the next smallest number at the right place. Now this is the last pass after the fifth pass, so that 1, 3, 4, 5, 6 and 8. So basically what is the procedure for the selection sort? We'll start with the first element, we'll compare with the smallest number, we'll exchange with the smallest number, then we'll choose go to the second smallest number, we'll replace with the second smallest second place, again we'll find the third smallest number, we'll replace with the third place, we'll find the fourth smallest number, we'll replace with the fourth place, and so on. So finally we will get the final list of the selection sort. So we can, in this way we can do this selection sort, and this is the end of this selection sort. Thank you.